Welcome in this project. Let's see what we have in the board. There is an RTC full operation project with a 4 by 16 LCD here. We have the 4 buttons for changing time, date, changing alarms and setting alarms, and plus and minus. Also here is the module, the DC3231. We have a power supply there and 3 LEDs. The blue LED is just for informing us that the code has been loaded correctly. The white LED is give us information about the status of the alarms, and the red one is the status of the screen. So that means when the screen is in a default, showing time, date and everything, the red LED is off. If we press, as soon we press the button for changing the time, date, or the button for changing the alarms, this goes on and goes off when we finish with the settings and we return back to the default screen. I didn't want to use blink function and buzzers because it will be very loady. All the code is written in a very simple C language. It's for beginners, okay? It's really can do a lot of improvements surely, but I keep it very plain for people that starting and want to have quick results. You see below the video is the files with the code, and also the code is full with all the files you needed. You don't need to search for anything. And also there is a document that gives you more informations and some instructions if you change MCU. I'm using PIC 16F1829, and it's very easy with the code. As the code is, it's very easy to change your MCU. Now let's take a quick overview of the code. Here is the main. There is a global definition file which includes all the global definitions used across the code, such as buttons and the indicator LEDs. Then we have the I2C bus communication LCD, which I have together put them in one file, the I2C bus communication and the LCD. And we have the read-write alarm and read-write clock date files. There's also a main functions, RTC main functions library, which includes functions and variables that are using also all across the code in all other files. So I put it in a general file which is included everywhere. Let's see. This is the main. The main includes, normally with all the includes, and the clock is in 4 MHz. We initialize the I2C bus and we initialize the screen. There is a welcome message here to be sure that everything works, and in the while loop is 3 F statements. One for the set clock date button, one for the set alarms, and the third one is manipulating the plus and minus button pressed when we have an alarm occurred already. With this function, with this if statement, we update the status of the alarm. So if the alarm is if the alarm is ringing and we shut it down, then at the same time we update the module, RTC module, that this alarm is off, and if the second alarm has a state on, remains on, and vice versa. And then we have we call the three function, time display, read temperature, and alarm display. Now let's go and see the read and write. First we have the first function we have here is the time display. We read the RTC with the function read DS3231, which includes in the main function library.c. After we convert this data to decimal, so we can store them on the time and date arrays, and then we just reproduce we show these arrays to the LCD. Then we have the read temperature, a very easy function also. As you see, everything is commented as good as can be. Then in the beginning, just to notice that the temperature is in two registers, 8-bit each. Okay, so we have the most significant and least significant bits. Here, if the most significant bit is less than 0, so we have that is minus. So we set the first element of the array is a minus. If not, just a space. This here we arrange the third. It's measuring up to 3 digits after the decimal point. So we need to declare, we need to fix the first one if it's 1 or 0. So it depends if you measure Fahrenheit or Celsius. If it's Celsius, it's not needed. I don't think so. But if it's Fahrenheit, you're gonna need the third. And then we arrange the decimal points here. This is the degree simple, and then we display it. After we have the edit clock. So if we go back in the main, when the button of the clock and set time is pressed, we wait until it's depressed. We set the position to first position of change. This is 0. First position is ours. We change, turn on the indicator, the red LED, and then we call the function. The function here has a new screen which says that we are in the mode of set clock, okay, and she recalls back the date and the time. Then we go in the while loop, and the second while loop has to do with when we press minus or plus button. It depends. If we press plus, the variable add is equal to 1. If we press minus, the variable add is minus 1. Then we following by a switch function, which takes the position here. So we start with 0, so we are in case 0, and we change the hour, and every time we make the change, we show the new time on the screen, and then we break from the switch. We go down here. There is an if statement checking if the position is higher or equal to 6. If it's not, we go down there, so the position is less than 6, and we have pressed again the button set clock. So when we do that, the positions is increasing by 1. So we'll go in 1. Then we are still in that loop. So we're still here. So we're still number 1 now. We push again the button, and again the procedure goes here, but in case 1 this time, because already the position is 1. We change the minutes. We change the date. This day value is the day that we load on the module. The module doesn't have the words Monday, Tuesday for the days, has only numbers, which starts from 1 to 7. 1 is Sunday and 7 is Saturday. and then we call the find date of week. We want to find the word that represents every value of day and we present it on the screen. Then we follow all the same things following until all the adjustment has been done. So when the adjustment has been done, this if statement is true and we break out. So we break out from the end while loop and we update the clock. We send the new settings, clear the LCD to be ready for the new data, and then we turn off the indicator, the red LED, and we return 0. We get out completely of this function and we go back in here from where we call the function, and the program still goes on, then continues. We call again the time display and we see the new times and the new date on that. Going back, this is the update clock function. Is very simple. We just first of all we convert decimal to BCD all the new changes we have made in these variables. We just change them to BCD and then we just load them by the write data function, which is this one. I put it here details, so I didn't call the function, but you could do that. I'm just changing a few things to see how it's happened. You can use just only that one, or you can erase all this and just use the function from the main function library. Now, continuing, if we press the set alarm button, the alarm is completely the same, with a small change on the alarm status, which needs to be watched carefully. So if button set alarm is set, we do again the same. We set alarm position to 0. This 0 means hours of the alarm 1. Indicator red goes again on, and then we call the edit alarm, which is in this file. Now, this is the edit alarm. Here we have the same, another new screen for the alarm, and the same while loops, the same changes all the way, except case 0 is the alarm 1 hours, case 1 is alarm 1 minutes, and then case 2 is the alarm status. In the alarm status, we call the function on off. Okay, I will show you what is exactly that. The same way we're getting out from this function when we finished, and we again update the alarms. The on off function is a way you show on the display what exactly is the status of the alarm, plus you load that after you load these new values you have changed to the module. So while you press button plus or minus, this is the first line is let's say I didn't make that is reversing the data. Instead of using all these thing with previous status and new status and all this procedure, you use that line, and then you say that go set the LCD in the position you want and to where is the on off, and then you say if the alarm is equals to 1, he writes 0 on, if it writes off, and then when you finish the change you did and you press again the set alarm button, then the alarm position goes plus plus and you come out of you returning the new status, you returning the new status. Okay, and then you go back here out of the function in the place that you called in the point, so you were here and then alarm is +1, so go position is +1, so you are case 3. Case 3 you change alarm 2 hours. Already status here is already changed now. If it was 1 became 0, or if it was 0 became 1. In the same way it's the alarm status too. Going up here, in the first one is again alarm display void. Okay, here we read the alarms. This we bypassing it, we ignoring it. Also that is not needed. See the manual for that. Why? Then we read the control register and the status register. So this is the alarms, and this is the control register, and the status register became decimal, and they are on control register and status register. Now we display with the same way in the two alarms through the arrays, and this is the alarm 1 status equals control register and 1, because his position is 0. Here the position of the alarm is 2, and we need to move it in the first place. So alarm 2 status is control register moved by 1, left shift, right shift, sorry, by 1, and then we add 0, 1, and that's the status of the alarm 2. Alarm 1 in the 8-bit register is in 8-bit register is a bit 0, and that's bit 1. Now we have to present the status in a word on the display. So how we do that? Easy. If the alarm status equals to 1, we have on. If it equals 0, we have off. So that's the way we do it in the second alarm. From previous, when you change that and you load it, like you see in the end, is again an update, and the update, you have the alarm status here update. You see alarm 1 status, alarm 2 status, it's already, if let's say if both alarms was on, so status is 1 and status here is 0. With this line here you change that only, and the other one remains like it is, or vice versa, works. That's the problem. That's the code. I think it's very easy, and is commented everywhere, very detailed, and I hope it's very helpful for people that just starting like me, and they need more simple things to start. I'm gonna have another video again with the same project, but making some very critical changes. Will improve the way that it's working. And now let's see how our project works. So let's see what it's doing. As you see, we press set clock, we beat. There is a delay because of the way is the program, as I said in the beginning. So the red LED, we are in the function to change time and date. So the first position is already on. So if we press here, we change the hours. Okay. So I will put some other hour, 18, and then we press again the set button of the hour to change position. So we press 1, we change minutes, okay, and then we press again, and we go on the date. Let's say that we make Monday, Sunday, etc., Saturday. Let's go Monday. Okay, and then we change date. Let's say first, doesn't matter. We change month. Okay, and then we change year. goes up, goes down, let's go whatever, and then we press again. The LED is off and the new data is already there, temperature is in the end, and now we go to change the alarms. So we are gonna use let's change the alarm. Let's set alarms. It's a second. The same way, you are in, you see mode alarms. The first position is the hour. We made it 18, 17, 18. Let's say 30. Okay, one more. Oh, sorry, I jumped it. On, okay, and then we go there. Let's say 18, 18. One. Okay. Oh, I did set it, sorry. On. Okay. Both on. I pause a bit here, and when it's time I will come back to see the alarms. We are back now. Let's say it's 48. Wait for the white to come on. If the alarm occurs, the white LED has to light on. Here we are. So the first alarm is on by pressing here. The alarm is off. You see also the sign of alarm off 1, but the second one alarm is still on, waiting for his time. So let's pause again. Now waiting for the second alarm to come on. Again the same LED is going to light. You see that? So we press and is off. This time I pressed the plus button. As you see, there is some delays pressing the buttons and everything. If you go around the code, you will understand that this is happening because there is a code to execute it before reach the point to poll the buttons, because buttons are polling, with polling. In the next video it will be, all these things will be improved, and will be not so much delays. As you see, the counting also, as I said before, is every 2 seconds. Okay, that's folks. Thank you very much for watching. I hope I helped some people for that. If you have any comments or some advices or whatever, it's helpful, please write it down, and see you in the next video. Thank you.